Hi everyone, so now that we've talked about all of the different ways that we can solve systems of equations, now we're going to talk about special systems of equations. And special systems of equations are just systems of equations, they either have all solutions or no solutions. So let me show you what a couple of them look like, and we'll just start with the examples. So the first example, it's asking you to solve this system of equations with any method. And I obviously give you a graph on this, so let's graph it. The first equation on here is y is equal to 1/4 x minus 3. So I'm going to start at -3. Let's see, I'm going to draw this one in red. And because it's 1/4, I'm going to go up 1 and over 4. So let's see, 1, 2, 3, 4, which means that it's right here. And then let's do one more, which would go right here. So that's what my graph looks like right there. And then the next equation, the bottom equation, is y is equal to 1/4 x plus 2. So I'm going to go up 2 and then graph that one. Let's do that one in blue. So I'm going to start right here at +2, and then I'm going to go up 1 and over 4, and up 1 more and over 4, just to kind of create that same line. And obviously my lines aren't perfect, but we can see that these two things are never going to cross. The reason why they're never going to cross is because they have the same slope but different y-intercepts. So even if I did graph them a little bit wonky, they're never going to cross. When they never cross, that means that there's no solution, because the solution is where they intersect. Because they don't have a solution, my answer is literally no solutions. All right, let's look at the second example. So the second example is x plus y is equal to 3, -2x minus 2y is equal to -6. So this one, just because of the way that it's set up, we're going to do it with elimination because the x's and the y's are lined up already. And so what I'm going to do is I'm going to multiply, let's say that we want to try and get rid of the x. So what I'm going to do is multiply this top equation by a +2. The reason why I'm multiplying it by a +2 again is so that the -2x from the bottom and the +2x from the top will cancel each other out. So when I multiply that top equation by 2, I'm going to end up with 2x plus 2y is equal to 3 times 2, which is 6. And then I'm just going to rewrite the bottom equation. All right, now, like in elimination, we're just going to add them together. So our x's are 2x minus 2x, which gives me 0, which is exactly what I wanted. It cancels out. Then I'm going to have 2y minus 2y, which, again, it's a +2 and a -2, so they zero out or cancel out. And then on the other side of the equal sign, we have 6 and -6. Well, 6 minus 6 is 0. So I know there's a lot of zeros here, but basically it says 0 is equal to 0. Now, does 0 equal 0? Yeah, that makes sense, which means when it makes sense like that, but there's no variables left, like there's no x equals or y equals, that means that your answer is all solutions. Because no matter what you plug in for x or y, your two equations should be equal to each other. Okay, let's try another one with elimination, which is the third example. And this one is 2x minus 4y is equal to 13. And then -4x plus 8y is equal to -16. In this case, let's start by trying to get rid of the x's again. So to get rid of the x's in this case, I want to get that top equation to be a +4, so it cancels out with the -4 on the bottom. To do that, I'm just going to multiply it by 2. So when I multiply the top equation by 2, I'd have 4x minus 8y is equal to 26. And then on the bottom, I'm just going to rewrite the equation 4x plus 8y is equal to -16. All right, now let's add those things together. So we have a +4x and a -4x, which zero out. Then we have a -8y and a +8y, which again, zero out because positive and negative, same number, cancel out to be 0. Then on the right side of the equal sign, we have 26 minus 16, which gives me 10. So really what we have is 0 is equal to 10. Now, does 0 equal 10? No, that doesn't make sense. right? Because 0 is not equal to negative 10. So when it doesn't make sense like that and all of your variables are canceled out, there's no x's or y's, that means that there are no solutions. All right, now let's do one more example. Number 4. And this one, because you have an equation set equal to y in this case, we're going to use the substitution method. So let me hurry and write it down. So to use the substitution, I'm going to take that top equation and replace the y with 6x plus 14 because it tells me that y is equal to 6x plus 14. So let's rewrite that top equation. But instead of y, I'm going to say 6x plus 14. Now I'm going to solve for x. So to solve for x, I'm going to start by distributing by 3. So negative 18x plus 3 times 6x would give me 18x. 3 times 14 gives me 42 equals 42. Now we're going to combine like terms, and in like terms we'd have a negative 18x and a positive 18x. Negative and a positive are the same number, cancel each other out, so it's just left me with 0, or I could just like cross them out right here, and I'd end up with 42 is equal to 42. Now 42 is equal to 42, that makes sense, but all of the variables are gone, which means my answer is all solutions. And there we have it, how to solve special systems of equations.